here's an example of a stacked via and what that looks like. So it does take up less space, but again, it does come with issues. And I'm wondering if Steve Carney would like to speak to, stacked vias versus stagger, maybe as it relates to registration as well. Do you have any comments?
Yeah. So we do a lot of stacked vias. I mean the staggered vias are easy to manufacture because you don't need to fill them. But we do a lot of stacked vias. We stack vias on the on a usually it's a center core through hole conductive fill capped off, and then we'll start landing on that via and build out. One of the things that you want to do too with either stacked or anytime you get into a laser via, you want to use what they refer to as either a flat glass or a spread glass prepreg in there. It helps with the material consistency because you're always the way the laser works, it's a certain amount of energy is going to remove a certain amount of material. So the more consistent you have the material, the better off your laser vias are.
So, there's everything that Steve Carney mentioned is critical, as well as, is the material appropriate for stacked vias, and laser drilling in general. And, as those things play a role. And then what's the environment the circuit board will be succumb to. Here's a quick example of an 8-layer board with stacked vias. So 1 to 3, 1 to 4, and 5 to 8. So here, you have to make sure that, again, we're sticking to a 0.75 aspect ratio. So there would be a typical example where you'd want, like if you have 5 mils of dielectric, you'd want 6 mil drill size. And then you might have a space constraint in terms of how big the laser drill can be. So that's why it's important to talk to the fabricator to make sure the materials and the press out thickness that's going to happen is appropriate to your design, and it can also meet, your space constraints as well as any control impedance requirements. So that's how, those rules all play against each other in this type of a design.